Hey, welcome to the video series on learning data science from scratch. This is a 3-part series. Each video is about 20 to 25 minutes, and I promise you, you will learn data science if you do all 3 of them, even if you don't know Python at all. Check the description below this video and the other 2 for links to a tutorial that you can use to follow along with these videos. Let's get started. So first off, the tools that we're going to use today are Visual Studio Code and something called Anaconda. Anaconda is a tool that you can install that will make setting up your data science environment a lot easier. We have a video to show you how to do that in just a few minutes. You can pause, take a look at that video, and then come right back. It's not a complicated process. So to get started, let's first create a folder where we'll put all of our code. So I'm going to create a folder here, and let's just call it Explore Data. And then I'm going to open this in Visual Studio Code, and you can do that by just dragging and dropping the folder onto Visual Studio Code. Now we have our empty folder open, and we want to write some code. Now, data scientists use a lot of tools, but one of the ones they use the most often is something called Jupyter Notebooks. So if we look in our extensions here, we can install Jupyter Notebooks. The other item that we can install if we want to, probably better even, is just install the Python extension for Visual Studio Code, which gives you IntelliSense and linting and also Jupyter Notebooks. I already have this installed, so let's go ahead and create a new Jupyter Notebook. So we'll do the new file and call it student data. We're going to be working with some student data today, exploring students who passed and failed a class and trying to figure out what happened there. Let's go ahead and create this notebook here. And in a notebook, we have these things called cells, and we can write code in the cells and execute them. We can also use something called Markdown, and Markdown just lets us annotate student data, right? This notebook analyzes pass-fail data for a class. Okay. And then when we hit the little check mark here, it just adds that text to the notebook. All right, so let's go ahead and add a new cell and put some code below. So first off, we just need some data to work with, okay? So let's just bring in a Python list, which is what we have here. And we're gonna set it equal to the data variable. And that variable data now exists, but how do we see it? Well, there's a variable explorer here in Visual Studio Code, and if we open that and scroll down a little bit, here's our list here. It has 22 items in it. Another thing that we can do is that we can just print out from the cell what's in the cell, right? So we just say print data, and this will print that out below the cell here. So these are all of the items that are in the list. Now, lists are great for working with data in Python, but they're not so great for working with numerical values. And a lot of data science is statistics and math. And so there's a package called NumPy that actually has an array type that's better for this. So let's add a new cell here, and we're going to import NumPy as NP, okay? And then let's create a new variable called grades. And then we're gonna set that equal to NumPy, and we're gonna create a new array, and we're just gonna pass in that data object that we have from the first cell, which will give us an array. And then let's just print out that grades object here. Okay, so these two objects look the same. What's the difference? Well, the most obvious difference is that there's commas here, but not here. But the real difference is that the array, this here, is much better for doing mathematical operations. Let me give you an example. So up here, if we take this data list object and we multiply it by 2, what do you think will happen? Let's run it and find out. It actually doubles the number of objects in the array, right? So here's the first set, okay? And then here's the second. It literally took the array, multiplied it by 2, and gave you twice the objects in the array. Okay, so what happens when we multiply this grades object by 2? In this case, it takes the array and it multiplies each item in the array by 2. So arrays in NumPy are much better for working with numbers, for doing mathematical operations on those numbers. All right, so let's go ahead and keep on working with this array object here. Now, one of the things that we can do is we can take a look at the shape of this array. So let's do that. So we can see that there are 22 items in this array. Another way that we could see this is if we go back to the variable explorer here, here's our grades array. We can open that up and take a look at it. And you can see here the same thing, 22 items in the array. And when the variable explorer launches here, we can see all of those items here. Now, notice that each one of these items has an index, and this is added for us automatically. And arrays start at 0. Okay, so the first item is always in the 0 position, and then the second item is actually in the first position. When you first get started with programming, it's a little tough to wrap your head around, but you'll get the hang of it very quickly. So knowing that, let's look at how we can get items out of this array. So for instance, if we wanted the first item in the array, because arrays start at 0, we would put 0, and this would give us the very first item. That's this item here, okay? Now, if we wanted to get the 47, that would be 0, 1, 2, right? So if we change this to 2, we should get 47. And if we wanted this 3, that should be 0, 1, 2, 3, 4, 5. This should give us the 3. Okay, so what else can we do with arrays? Well, we can do mathematical operations on the whole array. So for instance, if we wanted to figure out what the mean score was, okay, so the average test score here, we could do a mean on the array, and we see that it's a 49. Must have been a really hard test. So what we want to do here is determine why the scores are so low. So to do that, we need to bring in some additional data into this array. And what we want to do is bring in the amount of hours that each student studied along with their grade. So let's go ahead and add in this study hours, a list item here. And then what we want to do is just say we have a student data, new object called student data, and we're going to set that equal to the NumPy array, okay? And then inside of that array, we want to have two objects. We want to have the study hours, which is the number of hours each student studied, and the grades, okay? And what this is going to do is create an array with two arrays inside of it. Let's go ahead and run this. So let's take a look at this in our variable explorer here. So if you pull it up, you can see we now have two arrays inside, and each array has 22 items. And if we were to pull that up here in the variable explorer, here's the array 1, which is the study hours, and here's the second array, which is the grades. Now, when you're working with an array that has multiple arrays inside of it, how do you get a single item from one of those arrays? Well, let's take a look at our student data here. And if we pull back the first item, the item in the 0 place, we're going to get the first array. And if we want the first item from the first array, can you guess what we need here? Another 0. So we're going to get the first array, first item from first array. So it should be 10. So let's run that. Right? If we wanted the first item from the second array, that would be 1, 0. Okay? All right, so let's do some analysis here. So let's go ahead and do a couple of things. First, we want to get the average study time. So let's go ahead and create a variable that's the average study. And let's get the student data, right? And the study hours was in the 0 position, the first array. So we're going to get the mean of that array, the average. And then let's get the average grade. Okay, so that would be student data, same thing here. And actually in vscode, we can just copy this line down with Command or Alt-Shift down. It gives us the line over, and it just makes it easier for us to code here. So we can say average grade, and then we'll just change this to a 1. And then let's go ahead and print out what this is. So in Python, that's a print statement. And you can use this formatted string, so F, and then a string. And we can say average study time, the colon, and then we use these little brackets, and we can put the variable right in there. So average study. And then on another line, which is \n, we'll put the average grade, same thing, average grade. And you can see Visual Studio Code's helping us out here. This character here is called a carriage return, line break, just puts this text on a different line. Whoops. Okay, let's run this. And the average study time was 10 hours and the average grade's a 49. How'd you like to study for 10 hours and still get a 49? I'd like to know what was on this test. When we're dealing with multiple arrays inside of an array, it can start to get kind of confusing, right? Just the idea of having arrays inside of an array starts to get tough. And so there's a package called Pandas that will allow us to work with this data in a table, which is going to be something that looks a lot more familiar. So let's do that. So let's add a new cell here, and we're going to import a package called Pandas. Now, if you're running this and you get an error saying that the package couldn't be found, what you can do here in your terminal, if you have Anaconda like I do, is that you can just issue a conda install command and then install the package that you're missing. So in this case, we could run conda install pandas, and that will install pandas. So if you run into any of those missing package errors, give that a shot. Let's go ahead and make our data set a little bit more complicated. So to do that, what we want to do is create this thing called a data frame in Pandas. A data frame you can think of as a table. And we're adding some data here. So we're actually putting the name of the student. So this is new data. And then we have the student data, right, which is our study hours, the first array from student data, study hours. And then the second array from student data, the grade, we're putting in grade, right? The difference here is we're actually naming these things now, so we actually know what they are. And we can go ahead and look at this thing, which is called a data frame, and see its structure. So we can print it out here from the cell, and you see it just looks more like a table. We're still working with multiple arrays. This is a structure that probably just makes more sense to your brain. This is called a data frame. It's provided by Pandas. The other way that we could look at this is if we come to the variable explorer here, and we go down and look for our DF students, which is our data frame. You can see there's 22 elements, and it's got 3 arrays inside of it, right? But when we open it up, it looks more like a table, which is a data structure we understand, kind of like a spreadsheet. All right, so how do we work with data frames? Well, let's take a look at how we can get an item out of a data frame. So in a data frame, let's say we wanted to get the first item. Now with an array, we would just do 0, right? So if we wanted the first item from the first array, it would be 0 and 1. If we run this on the data frame though, we get an error because data frames don't work that way. What we need to do instead is we need to use the LOC method. And then we can pass in and say, give us the first item here. And the first item it's really a row, right? So it's Dan's study hours and Dan's grade. It's that first row. And if we were to go back and look at the data frame right here. So if we wanted, for example, Vicky in the 5th position here, we could go ahead and just pass in 5. And that will give us actually Vicky, who only studied for an hour and got a 3. Ouch. Now, let's say that we only wanted to know the grade from Vicky, right? So we want the item in the 5th position, but we only want the grade. So we can actually pass in here as a second parameter, the column that we want back. And because the data frame knows about the column names, we can just tell it the grade column. And if we run this, we just get back the 3.0. And if we change this to name, we should get back just Vicky. So there's a lot of other ways to get stuff out of data frames and searching for data. So one of the ways is to use filter expressions. So we can take this data frame of students and we can say, for the name column, give me the data where the name equals Vicky. That's what this expression says here. So let's run this and we get Vicky and her study hours and terrible, terrible grade. Now, another thing that we could do here, instead of doing it this way, is we can use something called the query method. So we can write query here, and then we can actually write a query, which is a string, but it's essentially the same thing. We just say where name equals Vicky, but Vicky has to be in quotes because Vicky is a string data type. So if we run this, we should get back exactly what we had before, but we don't because I left out an equals. The double equals is important, and now we should get back Vicky. There we go. All right, another thing that we can do here is if we go back to the way we were doing it before, where we're saying df students, we can actually just hit the dot here, and then the data frame knows about the columns that it has. So it knows that there's a grade column here, right? Or it knows that there's a name column, and then we just do equals and say Vicky, and run this, and we'll get back Vicky. And this is the method that we'll be using for sort of the rest of this video to access data in a data frame. All right, so those are the fundamentals of a data frame. Let's sort of back up and take a look at a more real world scenario, something you might actually do. So it's common in data science to import data from some sort of an external source. In this case, we're pulling in a CSV file. So we're downloading a CSV and then we're loading that CSV into a Pandas data frame. So we're reading in the file, the delimiter is a comma, and we're inferring the column headers. So let's just run this so that we can see how it works. So if we run this here and then look at our file explorer, you'll see that the CSV file actually gets downloaded, right? And here's the CSV file. Here's the name, the study hours, and the grade. It's kind of like a table in comma separated format. So what we have here, and let's go ahead and clear the cell output to make this a little less messy. And if we look at this data frame again, this DF students, it's going to look exactly like it did before, only this time the data has been loaded from this CSV file instead of us just loading static data. Because usually data scientists are working with lots and lots and lots of rows, thousands of rows. But this data is a little bit different. And the difference is that it's a little bit more real world. And one of the ways that it's real world is that there are some null values somewhere in here. Okay. So one of the first things that data scientists have to do is they have to clean up the data so that they can actually work with it. So in this case, to find any missing values, we can say df students and then just look for is null, right? So if we run this, it will tell us whether or not the value in each column is null or not null. So in this case, false. It's not null in any of these places, but this isn't super helpful for us. There is a better way for us to see exactly which values are null. So first of all, we can here and just say sum and just get a sum total of how many values we have that are null in each column. So there's one value that's null in study hours and two values that are null in the grade column. So the next question is then, well, what do we do about that? Well, there's a couple different things that you could do. One of the things that we could do here is we could go ahead and replace any missing value with an average value, right? So for missing a grade for student, one of the things we could do is just replace that with the average of all the other scores since we don't have a score for them. So what we can do here is we can fix just the study hours column to start with. So let's go with df students and then study hours. So we're going to set that equal to, and then we're going to fix the missing values inside of that column. So we're going to say df students dot study hours dot fill in A. And basically we're telling it we're going to fill in all of the missing values. And then in the parentheses, we need to tell it what we're going to fill it with. So we're going to fill it with the study hours, and we're just going to calculate the mean of all the study hours, and we're going to fill any missing study hours values in that data frame with the average. All right, so if we go back and run this, we should see that study hours now shows as having 0 null values, right? Because we filled in the one missing value with the average. The problem with that is that it kind of makes your data not correct, okay? And the reason for that is because you don't know if the student got the average. They could have gotten less than Vicky, right? And pulled the whole average way down. And so sometimes it's better to just delete any null values in a data set, which is commonly what a data scientist will do. So let's go ahead and do that. So we're going to set our whole data frame here, and we're going to set it equal to df students, and then we're just going to use the drop in A to drop any rows that have null values. So to do that, we need to tell it which axis we're looking at. Rows are axis 0, columns are axis 1. Right? So if we set axis 1, it would drop columns. We don't want to drop columns, we want to drop rows. So we say axis 0. So if we do that and we run this, and then we go back and look now, we'll see that we don't have any null values, right? We've just dropped the rows that had null values in them. All right, so let's go back to where we were before when we were working with our arrays, when we calculated the mean study time and the mean grade, and we just printed that out. This is that same thing, just with a data frame. So the average study hours, 10.5, average grade, 49.18. So let's go ahead and get all of the students who studied for more than the mean amount of study time. So to do that, we'll take our data frame of students and we'll say, give us everywhere where the study hours was greater than the mean study time, okay? Let's go ahead and run this. And now we get everybody who studied for more than the mean amount of time, which I believe was 10.52. So this is everything that's more than 10.52. So it would be interesting to know here, for these people who studied more than the average, what was their average grade? Well, since this actually returns another data frame, as you can see here, we can just say for this grade column, give us the mean, right? What is the mean grade for everyone who studied more than the average amount of hours? So if we run this, we see 66.7. If we assume that a 60 is passing and the mean is 66.7, it would be nice if we could go ahead and flag in the table who passed and who failed. So we want to add a column to this data frame, which just says whether or not someone passed. So to do that, let's create a variable called passed. It's going to be our new column. And then we want to use this thing called series on PD. And you see the little yellow squiggly? It's because we haven't imported pandas. We did, but then we deleted that cell. So let's go ahead and put it back here. There we go. And in that series, what we want to do is just say from the data frame here with the grade, was the grade greater than or equal to 60, right? This returns a true if it was and a false if it wasn't. And it puts those trues and falses in the passed variable. And then we want to take that data frame and we want to concatenate here this passed column onto the rest of the data frame, adding a new column. So we're going to say we want to take the students here and we want the passed column, and then we can take this opportunity to rename it and just make it say passed here with a capital letter. And then finally, we need to tell it what axis. Are we trying to append a row or are we trying to append a column? Remember, rows are axis 0, columns are axis 1. So we'll say axis equals 1. So this should append a new column to our data frame. So let's run this. And then let's go ahead and come back to our data frame here and refresh. And look, we have a new column with a false or true about whether or not someone passed or failed the test. Now, because data frames are designed for tabular data or data that's in tables, we can perform all sorts of operations on it. For instance, we could put students into two groups, those who failed and those who passed, and look at the data that way. And that's called a group by. So let's do that. So in our data frame here, we're just a group by. And then what do we want to group by? Well, we want to group by the students, and we have that new passed column that we added. Very handy. And then we want to get the count of how many passed or failed in each group. So if we run this, it tells us who passed, how many, and how many failed, but it does it in the table format, which is kind of hard to look at. So if instead we just take the name, right? If we group by just one dimension, the name, and we run that, then we'll actually get just one set of numbers here. 15 people failed and 7 passed. Crazy hard test. Now, what if we wanted to know for all of these students, what was the average study hours in grade for those who passed and those who failed? To do that, we can just print out our data frame here of students and use the group by. And we want to group by that passed column. And then we want to know, though, from that, we want to know the mean of the average study hours in grade, or the average study hours in grade. So we could look at the grade and then say mean like this, but this will only give us the mean. If we want to get the study hours and the grade and the mean of both of those. So to do that, we want to take our data frame of students, we want to group by, and we want to group by whether or not those students passed. But we want the mean of both the study hours and the grade. Well, because we know that this is actually a data frame itself, when we group it, we could say grade and then give us the mean. And if we run this, it actually will give us that. But if we want the average study hours and the grade, how do we do that? We can actually do both of those at the same time using this array syntax here and saying, give us the study hours and give us the grade, and calculate the mean of both of those. So if we run this, you can see that we now get the average study hours for those who failed, 8, and those who passed, 14, and the same with the grade. So we can do both of those things at the same time using that syntax. So the last thing I want to show you here is that data frames are really versatile, and you can do a lot with them, including like sorting the data in descending or ascending order. Now, these data frames that we've been looking at, they're really versatile, but one of the things you might have noticed is that when you alter a data frame, you have to assign the value back to the original data frame. If you make a change to the data frame and you don't assign it back to itself, it doesn't actually affect or change the data frame. So what we can do is come in and say our data frame, and then we set it equal to itself. We're going to sort it. Let's say we sort it. Let's say we want to sort it by grade, and we want to sort it just ascending by grade. So let's go ahead and run this. And then let's come back to our data viewer and refresh. And we should see, yep, Vicky and her terrible grade there at the bottom. sorted by grade. If we wanted to sort by name or study hours, let's say study hours. And then if we wanted to do it in reverse, right? We wanted to say highest to lowest, highest first, then we would say ascending is equal to false. And if we run that, come back to our data frame, we should see study hours, the most at the top, descending here. And we do, descending. Okay, now you understand the fundamentals of how to work with data. So the next step is to proceed to video 2, where we're going to learn how to create charts from that data.